Hello friends, welcome back to my channel Varteta Learning Platform, and in this video we are going to discuss about the virtual tables. Virtual tables are basically maintained to call the functions at runtime, to decide what functions need to be called at runtime. For that, the virtual tables are maintained by the C++ runtime. Okay, so let's first take an example and see how these virtual tables are maintained for various functions. Suppose I have a class shape, and in this class I have two virtual functions, virtual void draw1, and there is another function virtual void draw2. Okay, suppose draw1 draws in 2-dimensional and draw2 draws in 3-dimensional. Okay, so let's see. If I create one more class, the name is line, and I inherit it from shape. Okay, and I also have two functions here, void draw1 and void draw2. Okay, so these functions have been implemented as well. Okay, I'm not going to declare them. I'm just putting it like these two curly braces to show that yes, they have already been implemented. And one more thing, here you can see like in the top class I have written virtual keyword. I have used the virtual keyword, but here in the line class I have not used the keyword virtual before this draw1 and draw2. So if you have taken the same name and if you have taken the same signature of the function, signature means the number of arguments, the return type, everything. If it is same as the base class, then in that case this function and this function will also become the virtual functions. They are also considered as virtual if the names are same, if the signatures are same, right? So the shape class, the line class, which have been inherited from the shape class, and it has a virtual function. So this class and this class, both the shape and line class, they will contain separate virtual tables. Okay, let me show you how they contain the virtual table. Okay, so let me first draw the virtual table for the class shape. Suppose I'm talking about the shape class, so in that case, in this virtual table there will be two columns and two rows, right? First one will be the name of the function, the name of the function, suppose. Okay, let me just draw the correct name, draw1, and there is another function, draw2. So there are two functions, draw1 and draw2. It has some address, suppose 0x something 0012, something like that, and this has some other address, 0x012334, something like that. Okay, so this draw1 has been pointed by this 0x010, and this draw2 has been pointed by 0x01234. So this address 0x010, this is the base address of this table, right? So this table starts from here. Okay, and the functions draw1 and draw2, they will be in the same sequence as you wrote in this shape class. You have written in this order draw1 and draw2, so they will be in the same order, draw1 and draw2, in the table itself. So the very first function, the address of the very first function will be the address of this table. This will be the base address of this table. Okay, so when this will be the base address of this table, then how it will decide that how to call the function, how to call the next function. So this address 0x010, this will be pointing to the base address as well as the very first function, and after that there will be an offset. This offset, I means where to start the second function. So it will start the second function after the 4 bytes. So 4 bytes will be the offset for the second function. If there is a third function, then again the 4 bytes will be there, and then it will reach to the third function. Okay, so basically this address is 4 bytes. So after the 4 bytes, it will the next 4 bytes will contain the next address, the address of the next function, right? So this is the way the base class whose name is shape, the functions, the virtual function table will be maintained. Okay, so at runtime, if you create something like this, shape is equal to shape asterisk s is equal to new shape. So as soon as you run this new shape, or you write something like this, like shape s, either this or you do this new shape, which means whenever the constructor of this shape class will be called, and whenever the object will be created for this shape class, at the same time this table will be created. So first thing that you need to note is that virtual table is created when object is created. Object is first created. This is the first thing. As soon as you will create this class object, the virtual table will be created. And the second thing is that only once or only for the first time virtual table gets created. Only once it will be created, right? So you can think of a virtual table, or you can say the way virtual table is implemented is an static array of pointers. Okay, you know that anything which is static, it will get initialized only once. Whenever you create a static variable for any class, then the same value or the same thing will be available for every object of the class. Available same value for every object of class, right? So a static class initializes only once, and any change in this static variable will be reflected in all the other objects of that class, whatever objects you have created. So I hope you know this concept, the static concept. So that thing you know. So similarly, you can think of that this virtual table is a static array of pointers and nothing else. Something like that is implemented. Okay, so this table will be created only once, this thing, and for every object this thing will be same. Okay, this table will be same for every object. And there is one more thing that you need to remember, is that virtual table pointed out by a pointer inside class, and this is added by compiler. You don't add it, compiler adds it. Whenever there will be a virtual function in your class, compiler will secretly add this pointer, which is represented by vptr, right? This vptr will be same for all objects. Value will be same for all objects. It will be contained by all the objects. If you create obj1, obj2, obj3 of the class shape, there is a class shape, and you created 3 objects, object 1, object 2, object 3, and all these will contain same vptr, right? They will contain VPTR. This will also contain VPTR. This will also contain VPTR, but the value in this VPTR, which means the address of this table will be same, because there is only one table for every object, right? So table is created only once, and that table is shared by all the objects of that class. So that's the basic funda. This is shared by all the objects. Every object contains the VPTR. Okay, and every object VPTR contains the same address. I hope you got why it contains the same address for all the objects, right? So this VP, whenever you have the next point is that whenever you have a virtual function in your class, which means that you have a polymorphic class, in that case, first 4 byte of an object represents the VPTR, which means the address to the virtual table, right? So if your class contains any of the virtual function, then if you create the object of that class, then in that case the first 4 byte of the object will contain the VPTR, which means the address of the virtual function table. Okay. Similarly, now we have talked about the shape function, class. Now we will talk about the class line. So we are going to talk about the class line. So in the line class, what will happen? Same virtual table will be created, same way, right? Same way the virtual table will be created. Draw 1 and draw 2. I have just written 1 and 2. So draw 1 and draw 2 will contain separate addresses, right? Because line has separate functions, draw 1 and draw 2. So that address will be contained by the object of the class line. Okay. So if you write something like this, shape asterisk s is equal to new line, in that case what will happen? As soon as this new line will be encountered, this table will be created, and the first 4 byte of this s, this shape asterisk s, shape is pointing to line. So the first 4 byte of this shape asterisk s, the s variable, will contain the address of this virtual table for the line. Okay, so this will contain the virtual this will contain the address of this virtual table for the line class, right? And it will be initialized only once. The same story will be everywhere, but in the shape asterisk s, in s, now it will point to the virtual table of line. It will not point to the virtual table of shape, because shape's virtual table has not been created, and even if it has been created, it is pointing to line. So it is not going to point to the shape virtual table, it is going to point to the line virtual table. Okay, virtual table of the line. So this is how the virtual tables are pointed to by the various pointers, various base class pointers. So once the line object has been created, the virtual table will be created, and now if you create shape asterisk s1 and you write like new line, then in that case as well, this s1 will also contain the same address of the virtual table. This asterisk s VPTR is also containing the same address of the table, and this asterisk s1 is also containing the same address of this table. Okay, so this is how the virtual tables are created. Okay, and this is how they are accessed. So as soon as you write like s2 draw 1, in that case what will happen, that at runtime it will be decided that to what type of object it was pointing to. It was pointing to of type object line, or it was pointing to of type object rectangle or circle, or whatever type of object it was pointing to. And based on that, the virtual table will be created, and based on that the function will be called based on the address of the virtual table. Okay, and you already know that how the functions are maintained, in the same order in which they have been defined or they have been declared inside the class. And first 4 byte of every object, when there is a virtual function, then first 4 bytes of every object contain the address of the virtual table, and there is a 4 byte offset, which means that after the 4 bytes, next 4 bytes will contain the address of the next virtual function. So this is the way your shape class is going to call the function at runtime, the correct function at the runtime, right? So this is the way the virtual table mechanism works for the virtual tables, or you can say for the polymorphic classes. I hope you got the point in this video, that how they are created. In the next video, you will see that how we can implement it and how we can see it running. Before I conclude for today, let me tell you one more thing, that suppose in your shape class you have two functions, draw1 and draw2, right? So make a note. In your shape function, you have two functions, draw1 and draw2. Suppose you don't have any virtual function with the same name in the derived class, say line. Then what will happen in that case? If no virtual function in derived class, then the virtual table of base class will become the virtual table of derived class. Okay, so suppose if your line class doesn't have any draw1 and draw2 methods, then in that case the draw1 and draw2 methods of the base class will be the methods for the line class, which means the table created for shape class, the virtual table created for the shape class will be the virtual table for the derived class as well, which means for the line class as well. Okay, so this is the point which you need to note, and I hope all the 4 to 5 points that we have discussed today, now they have been clarified to you. And with that, I would like to conclude for today. And in the next video, you will see programmatically that how we can implement this virtual function concept and how we can see the various various variations of the of this concept. We will basically practice different functions, different questions, different we will do different exercises basically, and then we will see that basically we will play around with all the concept, play around with the different questions, different set of codes, different piece of codes to understand thoroughly the concept of virtual functions. Okay, so till then, have a nice day and bye bye.